How do I initialize weights in PyTorch? How do I initialize weights and biases of a network, via for example your Xavier initialization?
Single layer. To initialize the weights of a single layer, use a function from torch.nn.init. For instance. Alternatively, you can modify the parameters by writing to conv1.weight.data, which is a torch.tensor. Example. The same applies for biases. nn.sequential or custom nn.module. Pass an initialization function to torch.nn.module.apply. It will initialize the weights in the entire nn.module recursively. Apply fn applies fn recursively to every submodule, as returned by children, as well as self. Typical use includes initializing the parameters of a model, see also torch nn init. Example.
We compare different mode of weight initialization using the same neural network NN architecture. All zeros or ones. If you follow the principle of Occam's razor, you might think setting all the weights to 0 or 1 would be the best solution. This is not the case. With every weight the same, all the neurons at each layer are producing the same output. This makes it hard to decide which weights to adjust. After 2 epochs. Uniform initialization. A uniform distribution has the equal probability of picking any number from a set of numbers. Let's see how well the neural network trains using a uniform weight initialization, where low equals 0.0 and high equals 1.0. Below, we'll see another way, besides in the net class code, to initialize the weights of a network. To define weights outside of the model definition, we can define a function that assigns weights by the type of network layer, then apply those weights to an initialized model using model.applyFn, which applies a function to each model layer. After 2 epochs. General rule for setting weights. The general rule for setting the weights in a neural network is to set them to be close to 0 without being too small. Good practice is to start your weights in the range of y, where y equals 1/sqrtn, and is the number of inputs to a given neuron. Below we compare performance of NN, weights initialized with uniform distribution, 0.5, 0.5, versus the one whose weight is initialized using general rule. After 2 epochs. Normal distribution to initialize the weights. The normal distribution should have a mean of 0 and a standard deviation of y equals 1/sqrtn, where n is the number of inputs to nn. Below we show the performance of two NN, one initialized using uniform distribution and the other using normal distribution. After 2 epochs,
To initialize layers, you typically don't need to do anything. PyTorch will do it for you. If you think about it, this makes a lot of sense. Why should we initialize layers, when PyTorch can do that following the latest trends? For instance, the linear layers _init_ method will do K-means initialization. Similarly, this holds for other layers types. For example, conv2d, check here. Note, the advantage of proper initialization is faster training speed. If your problem requires special initialization, you can still do it afterwards.
If you want some extra flexibility, you can also set the weights manually. Say you have input of all ones. And you want to make a dense layer with no bias, so we can visualize. Set all the weights to 0.5, or anything else. The weights. All your weights are now 0.5. Pass the data through. Remember that each neuron receives 8 inputs, all of which have weight 0.5 and value of 1, and no bias, so it sums up to 4 for each.
If you want to see more, please consider subscribing.